Okay, so we have two topics to cover this afternoon. One is Oozie and the other one is Flume. I wanted to cover Solar as well, but I did not have a chance to create a content. So maybe next time we offer this Hadoop Code Camp, we are going to cover Solar. Okay. All right. So topic of Oozie. I love all these interesting names of Hadoop ecosystem technology. So here we are going to talk about what is and why Oozie, and then we'll talk about workflow definition file. So Oozie is actually workflow system, workflow technology. So we are going to see how you can define a workflow definition file, and then how you can create an application and run the application. And when you create the workflow definition file, you are going to use both control nodes and action nodes. So we're going to actually cover control nodes and action nodes. First, action node we are going to cover is a map reduce action node, and later on we are going to cover other action nodes such as a pick, email, things like that. And we are going to actually go through step by step for building and running this workflow application. Lastly, we are going to cover Oozie coordination. So what is and why Oozie? In real life situation, it's very common that multiple Hadoop jobs need to be performed in controlled and scheduled manner. For example, you might want to perform map reduce job first, and from the output of that job, you want to make it into the input pick job, and then you might in fact have some streaming information, streaming data coming from somewhere, and you might want to perform some HDFS operation like a make directory chat, chmod, or remove directory and things like that. There are actually a few other jobs that you can do, and you can actually control the flow of these jobs, and that's the time you can use Oozie. It also lets you do scheduled the workflow, meaning I want to have this particular jobs to be performed every 5 minutes or something like that. So Oozie provides workflow based on controlled and scheduled manner. And before Oozie was born, there were some ad hoc solutions, such as using, custom shell script or cron job and custom job control. And, these are all ad hoc solutions, and were not really providing the standard and common simple solution. And that's the reason Oozie was born as one of the Apache project. So Oozie is a server-based workflow scheduling system to manage Hadoop jobs. Okay, and Oozie server is actually built on the Tomcat. So it receives job submission from client, and then it will perform these jobs in a controlled and scheduled manner. So Oozie server is made of two main parts. One is workflow engine. So this workflow engine stores and runs these workflows composed of different types of Hadoop jobs. And there is also a coordination engine. And this coordination engine is responsible for based on predefined schedule or data availability. So you can run a job every 5 minutes or every hour of each day or something like that, or based on data availability, meaning when data is available on this particular directory, I want to run this Hadoop job. Okay, so coordination is actually responsible for running workflow jobs based on schedule and data availability. So this picture shows the flow. So client can send the request, a job workflow request. That could be done either at the command line. That's pretty much what we are going to do in our hands-on lab, or it could be done by Java Client API, or it could be Web Services API. So when Oozie server receives the workflow Java application submission, then it's going to launch that workflow job. Okay, talking to Hadoop. Okay, so exercise 0 is Oozie server. So let's take a look at the Oozie server. So if you click Cloud Manager, you should see Oozie 1. So Oozie 1 has just the one Oozie server. And you can take a look at the configuration. You click the Oozie server, and then you can see the configuration. And Oozie HTTP port is 11,000. Okay. And Oozie Web UI. So you can actually see the Oozie jobs, meaning workflow jobs status from Oozie Web UI. However, if you do this, you're going to actually see this message that you have to actually install EXTJS library. We're not going to actually install EXJS library because we are going to use Hue Oozie dashboard, which is in fact a lot better than the Oozie Web UI. Okay, so don't worry about it if you see this this screen. Okay. All right, so that is exercise 0. So I'm going to just move ahead with the next topic. So the concept of workflow definition file. So part of the workflow, I mean, the way that you want to execute your workflow is to define workflow definition file. So it's an XML file which defines what is called a directed acyclical graph of control and action nodes. Yeah, by acyclical, that means you cannot have a workflow to be how do you say, circular, I guess. You cannot, it has to be in one direction. Okay, so if you see this picture, we actually have a start node and end node. So every workflow should have a start node and end node. You could have a fork, meaning when you have a fork, then you are starting two jobs in parallel and then join. So once those two jobs are done, then it will be joined. So in this case, so if you see this picture, we are starting with a MapReduce job here. And by the way, the red colored thing is, those are called control nodes because that's controlling the flow. Action nodes are in green color. That is actually what actual task is being performed. So we perform the MapReduce job first, and then we are performing MapReduce and pick job in parallel. So both of them should be done before they got joined. Then we could also use the decision, the control node. Decision control node is basically if and else, okay, or switch, okay. And depending on the condition, we are going to perform MapReduce pipes, and then we can perform some Java operation, and then we can perform file system operation, and then it could be an end. Okay, so this flow should be defined in a form of XML file, and we are going to see an example of that in the following slide. So this is an example of workflow definition file. So as you can see, workflow element, and then we have a start right here, and then we have end. Okay. Typically, you're going to have at least 3 control node: start, end, and kill. Kill is that if there is an error when you're performing certain action, then it will go to kill. So in this case, we are starting from start to my word count. So it's actually pointing this action. So in this action, we are performing MapReduce job. So we have to define certain things such as job tracker, which one is the job tracker, and what is the address of the job tracker, what is the address of name node, and things like that. And then we have OK and error. Okay, so OK means if things were successful, then we are going to go my word count end node. So you can see the name basically is pointing to the node, and it is an end node. If there was an error, then it goes to kill. Okay, all right. So this is a very simple workflow definition file, which has just a single MapReduce job. Okay, in general, you are going to have a multiple of these actions with the control nodes. Okay, so workflow definition is made of control nodes and action nodes, and control nodes control the flow, as I said, and it should have start and end and possibly kill node. You should have at least start and end node. And you could have a decision node, and you could have a join and a fork node. And the action nodes, the one that actually performs a task. Again, it could be MapReduce task, a Java task, or a pick task, or a sub workflow. You can actually have a sub workflow from a flow, or it could be file system operations. Okay, so let's talk about the control nodes in a bit more detail. So start node is the entry point of your workflow job. Okay. So workflow definition file must have at least one start node. Actually, one start. I shouldn't say at least. It should have one start node. Okay. End node is the end for workflow job. It indicates the workflow job has completely successfully. Again, a workflow definition must have one end node. Okay. Kill node allows the workflow job to kill itself, typically when abnormal conditions is detected. Workflow definition can have 0 or more kill nodes. Okay. So in some cases when there is an abnormal situation, then you might want to actually start another job or something like that. Okay, or you can just display the message or something like that. So that's the reason you could have a 0 or more kill nodes, but you have to have one start node and one end node. Okay, now in the workflow definition file, you are going to have some parameters using this $sign notation. Okay, and this $sign notated variable, the values have to be defined in a properties file. Typically, you're going to name that properties file as job.properties file. So in this case, we are going to set name node as this, and the job tracker node is going to be set like this. Okay, and then these values will be inserted into this variable when job is submitted. Okay, all right. Action node. So we're going to talk about the map reduce action node first, and then we're going to talk about different action nodes later on. Okay. So map reduce action node, start with the action and name, and then the way that it knows it, the way it indicates it is the map reduce action node is having this map reduce element. And here you specify job tracker name node and prepare. So you might want to delete the output directory. Okay, otherwise it will complain that output directory already existent or something like that. So you could actually have a prepare action and prepare in this case deleting an output directory. And you can also have a job.xml file. So this is where you are going to specify various map reduce job related information. And configuration. So in this case, input directory and output directory can be configured. Okay, and then we have OK and error. Okay, so we just learned how to define workflow definition file. Okay, so now how we are going to create workflow application. Okay, and workflow application should contain workflow definition file. So in the Oozie, workflow application is represented by HDFS directory that contains workflow definition file. Typically is named as workflow.xml file, and all the necessary files to run that applications. To run that, the workflow application, which include multiple actions, such as, if you are running map reduce jobs, you need to have a job file. If you are running some kind of streaming things, you could have a shell, the Bourne shell or something like that. You might in fact have a native Java libraries. You might in fact have a pick scripts and other resource files. So everything that you need to perform the actions in your workflow need to be provided. Okay, and later on, these information have to be provided in a predefined structure. We're going to see that in the following slide. Okay. And once you have this directory structure, and then you copy this directory structure into HDFS, then you can submit a job. Okay, so you can submit a job using command line tool, or web services API or Java API. In our hands-on lab, we are going to mostly use command line, tool. And once you submit the job, you can monitor the system, and you can monitor workflow job. Again, you can do web console, command line tools, and web service API, Java API, and Hadoop Oozie web UI. In our example, we are going to use a command line tool and Hadoop Oozie web UI for monitoring the workflow jobs. Okay, so as I said before, workflow application is represented by a directory structure in HDFS. So typically, you are going to create that directory structure locally, and then you're going to copy from local to your HDFS. So in this case, we are going to have my workflow app, which contains a single map reduce action. So on the live directory, you should have a my map reduce jar file. And any other files that are needed for running your workflow application has to be on the live directory. And you also have to provide workflow.xml file. This is the workflow definition file that you have created. Okay? So this is the name of my workflow application. Underneath, you have to have workflow.xml file. Then you have to have a live. Okay? And this whole directory needs to be copied over to HDFS before you are starting workflow application. Okay. All right. So now we are going to actually do step by step for building and running workflow sample application. Again, here we are going to do just a map reduce job. Okay. So we have a single action node. So these are the steps. So step number 1, you are going to make workflow application directory with necessary files. Okay. You could actually use Maven, or you can just construct manually. Okay. In our case, we're going to just construct manually. Basically, you just create a directory that represents your workflow application, and then you're going to have everything on the live directory, and then you create workflow.xml file representing workflow definition. And then you are going to copy application directory to HDFS. Again, you are going to, in this case, you can use put command. Okay, so Hadoop fs-put, and this is the my application workflow application directory, and I'm going to copy into workflow/my workflow app directory. Okay, and then we are going to create the job properties file. So typically it's going to be named as a job properties file, and this is the one that contains the property and their values. And you don't have to have a job properties file in HDFS because this is used when you are submitting your job. Okay, so this one has to be present in the local file system. Of course, you can have it in the HDFS. Okay, but it's actually mainly when you're submitting a job. So when you're submitting a job at the command line, it's going to read this properties file from local file system. And then the way you are going to submit your workflow job is basically you say Oozie. This is a command line tool that you are going to use to submit a job. Oozie job -config, and this is the your job properties file that you have created here. And then you say -run. This is the way that you are going to submit your job, and it will return job ID. So in step 5, you can monitor running workflow application by saying Oozie job -info, and then you specify job ID. Then it will let you know what's going on with that workflow job. And step 6 is you verify the output, meaning whether everything worked okay or not. Okay. All right. So that is exercise 1. So let's actually go through this exercise 1. So let's go to Oozie sample project directory. So I have actually provided the sample project. So go to, okay. So, I have the Oozie ML word count. So this is the one that we are going to actually play around. So this is the workflow application, which contains a single map reduce job. Okay. All right. Now, before you do anything, you have to actually export your Oozie URL with this. So, you just want to make sure you do this. Export Oozie URL like this. Okay. Now, here, if you take a look at the Oozie ML word count directory structure, so I have provided all the working application already. I mean, you can certainly create this one, from scratch. So let's just see directory structure of Oozie map reduce word count. Okay, so you can see I have workflow definition file called the workflow.xml file, and on the live I have a word count jar file. So this is the jar file that we have created on our map reduce sample application. Remember, on the first day we were able to build this jar file, right? So I just copied it here. All right. And then we also have a job properties file. And we also have input data, like a WC input.txt file, input.toText file. And then we have word count ml file. Okay, so let's take a look at each of these files in a bit more detail. So this is the workflow definition file. So we have start node. It goes to my word count. So it goes to my word count action. Okay, that action happened to be map reduce action. So we have defined job tracker name node. We prepare, meaning we are going to delete the output directory, and this is the configuration file. And then we have input directory property, and we have, so input directory is word count data, so that's where we are going to use this data. Okay, you can certainly provide a different location. Okay, and we also and then we specify output directory, and then job queue name. So the default is job queue name is default. Okay, so you're basically sending this job to a default queue. So if everything is okay, meaning if everything has been done successfully, then it will go to example workflow end, which is this end node. So it will end it. If there is an error, then it will go to kill node. Kill node happen to be kill element. So in this case, we just display the message. Okay. All right, so what we are going to do is, let's actually take a look at the other information. So we just take a look at the workflow.xml file. Let's take a look at the job properties file. So job properties is basically defining the value of name node, job tracker, queue name, and so this one is basically I'm actually using all the Oozie library, okay, and this is the application path. So important thing is that these two, whatever properties that you want to define here, are going to be actually used in the workflow the definition file, okay. You can certainly have hard-coded name value here, but that's actually inefficient, right? Okay, so that's job properties file. Again, this job properties file is used in the local file system. Okay, now let's take a look at the config and word count ml config file. Okay, so it is word count ml config.xml file. So yeah, it basically defines, what is the important thing is what is the map reduce mapper class or reducer class and things like that. Okay, remember in our first day, we were using a driver, right? So driver is the one that actually configure all these things into a job, right? But in here, since we don't have a driver, we're actually asking the Oozie to run this guy. So we have to actually define, for example, the mapper class and the mapper class and the reducer class, and we also have to define input and output key and things like that. So whatever things that we have to specify in our driver class has to be specified as a configuration file. Okay. All right. So now what we have to do is we have to copy this directory structure to HDFS, okay, before you are submitting a job, okay? So we are going to use put command. So we are going to do, okay, so we have to go, yeah, so this is sample Oozie. So now we are going to copy this guy to workflow. So I probably have it. So it probably have, it probably says existent. But this is the command that you're going to use to copy this whole directory structure into HDFS. So the only thing that is not needed is the job properties file, but so we are going to actually copy it in anyway. Okay, so it's copied over. Okay, and we can just verify the files. Okay, in fact in HDFS. So we just do ls on workflow Oozie ml word count. Okay, so it's all there. All right. So now we are going to create the so we have okay, so we take a look at the job properties file already. Okay, and then this is the way that you are going to submit workflow job to Oozie. Okay, so you say Oozie, so Oozie job, Oozie job, and then you provide the config of your job properties file. So I'm going to copy this guy and then say run. Oops, not right. Okay, so I'm submitting a job, okay, and it will return job ID. Okay, so we return the job ID. Now we can check the status of this job by saying Oozie job dash info, and then you specify the this job ID, this guy. Okay. All right. So right now it's it's running. Okay. So you can see it started okay. Now it's running the MapReduce job. Okay. So if I do it again, it's probably still running. Okay. All right. And after some time, what we are going to see is success. Like everything is okay. Start was okay. MapReduce job is okay. And then workflow end. Each node ends with the okay. Okay. So let's just try one more time. So this is the way that you can find out the status at the command line. Okay. Yeah, it is still running. Now, another way that you can find the status of your job is from Hue. So we're going to actually go to the Hue. Let's go to Hue. So click Hue. And Oozie icon is see whether it's done. Okay, it succeeded. Okay, so we're gonna actually take a look at this this job from Oozie UI, Web UI. Okay, I shouldn't say web, the Oozie Web UI. I meant to say Hue, uh, the Oozie Web UI. So here we go. So this one is Hue. This guy. I'm sorry, the Oozie. Okay, so you click this guy. And and it should actually it should give you a list of all the Oozie jobs, workflow jobs that have been performed in the past. Okay, so is this the one? Oh, okay. So I think yes, this is the one we just This is yeah. So this is the one I started like October 14th and still doing it. So I'm gonna just kill it. But this is the one that I just started. Okay. So this is Wednesday, October 29th and 10:21, 10:26 Pacific time. So this is the one. Okay. So it succeeded. All right. And you can certainly take a look at the this job. You can find more information about that job. Okay. All right, so that's basically yeah. You can certainly search. You can actually have a job ID here, right? So I can actually have this one. I'll just copy this one, and I should be able to search. Okay. Yeah. So this one actually shows the graphical representation of it started. And then, yeah, so I think what I was trying to show you is when you have many jobs, you can actually search like this, okay? And so that's the one, okay? And then when you click it, it will actually give you the graphical flow of start. And in this case, we have one single action node and then end node. you can see the actions. In this case, this is a map reduce job. Okay, so you can again take a look at more information about it. You can see the details, how it happened, and you can also see the configuration. Okay, and you can see the log. So when things did not work, this is actually useful. You can take a look at the log file. Okay, and then you can also see the definition. You can take a look at the log file from the var, the /var.log and then Oozie. Okay, so you can certainly go to var log and Oozie, and then you can find out what is the job UID and to find the log file for that particular job. But it's a lot easier, you're looking at the log file from this UI interface, and this is the definition file. Okay, all right. Okay, so that is exercise. So we just take a look at all these things. Okay, so you want to actually verify. In fact, it worked okay. So the output directory is this, right? So we are going to actually take a look at the output directory. So we are going to go name node and browse file system, and it is on the workflows. And the one that we just run is ML word count, and it's on the data and output directory. And so as you can see, the time is 10:29 and Pacific time 10:27. So that is the one that we just have created. So this is the output. So this is the word count sample map reduce job that was just performed successfully. Okay. All right. So I'm going to give you guys 15 minutes to try this exercise 1. Now, we have seen a very simple workflow job that has a single action, map reduce action. So here we are going to make it a bit more complex. It's still relatively simple. So variations from simple workflow job. So we're going to actually exercise decision, sub workflow, and fork and join. So control node. So control node, decision control node is used to enable workflow to make a selection on the execution path to follow. So you can think of it as a switch statement. And decision node consists of a list of predicates, transition pairs, plus a default transition, just like a switch statement in Java. Predicates are expression language expressions that resolve into Boolean value, true or false. So this is an example. So, depending on whether the file size of a particular directory is greater than 10 gig or not, you might want to actually try different things. Okay. So let's see an example. So in this case, I have decision node called my decision, and I have a switch element, and switch element has a case. So if the second job output dir is greater than 10 gigabytes, then I'm going to go, the first one, reconsolidate job. And if it is less than 100 megabytes, then I'm going to go re-expand job. And for this counters, second job records reduce count is less than the 1 million, then I'm going to go to early compute job or something like that. And the default is end. Okay, so this is decision control node. Pretty straightforward. Fork and join. So fork nodes split one path of execution flow into multiple concurrent paths of execution. And join nodes waits until every concurrent execution path of previous fork node arrives to it, meaning all execution path has to finish. Okay, so this fork and join must be used in pairs. Okay, yeah. So join node assumes concurrent execution paths are children of the same fork node, so they actually have to share the same name. So we'll see example in the following slide. Okay. So here we have a fork the control node called forking, and then it will start the two jobs, first parallel job and second parallel job. Okay, so in this case, we have the first parallel job is MapReduce job, and second one could be something else, pig or whatever. And then we have a join. So its name is joining, and to next action. Okay. So in this case, yeah. So this fork and join has to be, working in sync. Subflow. So from a flow, you can create another subflow. So in this case, we have a sub workflow element, and then it provides the workflow.xml file. Okay. So we're gonna actually take a look at the example of that. Okay, so that is exercise 2. Okay, so again, the sample application is completely working sample application is provided. So name of the sample application is called Oozie example. Okay, so okay, so the one that we are going to run is Oozie example. So we are going to actually take a look at the tree structure again. Okay, so as expected, we should have a workflow.xml file. And again, we are using pretty much the same config and data because here we are going to have a same MapReduce job. So we have, Oozie examples.jar file contains MapReduce jar file classes as well as others. And you also have a subflow.xml file. Okay, so we just take a look at the, if you take a look at the workflow definition file, we have switch. So in this case, switch is actually the case. It will actually try either my word count map reduce job, okay, if wf config jump to is single. If it is parallel, we're gonna go to subflow. So subflow, if you take a look at this guy, is actually performing fork and join. Okay, and this map reduce job is exactly the same as we have seen in the exercise 1. Okay, now let's take a look at the subflow job. So this is the place that we are going to have a fork. So we are going to have a fork. So in this case, we are going to actually run the map reduce jobs. We are going to actually run 2 map reduce jobs, P1, P2. It's the same word count. Okay, we are actually running map word count jobs in parallel, 2 of them. Okay, and we do fork and join. Okay, yeah, right. Yeah, so this map reduce job. Okay, so in terms of so the this information wf config, okay, the wf colon config, okay, that is actually, you can specify when you run the code, when run real workflow application, you can define that jump to either single or parallel. Okay, so depending on what you specify when you run with the -d option, it will go to different different action. Okay. All right, so that is that, and then we take a look at the subflow, in which is actually doing a join, a fork and join. Okay. All right, so we're going to actually copy this guy into HDFS. And then we are going to, again, we take a look at the job properties file. Again, what we found if you're running CDH5.2, the name has been changed. If you're running CDH4, this is okay. But if you're using CDH5.2, it is changed to quickstart.cloudera. Okay, so you have to change that in this job properties file, and then you are going to actually submit. Okay, so we are going to submit. In this case, we're going to try with a parallel. Okay, so in this case, we're going to have 2 MapReduce jobs running in parallel because it goes to subflow, right? So let's do this. And we are receiving job ID, so we are going to check the status. Oozie job -info, and we'll take a look. Okay, so it started okay. Now it's actually doing, it goes to subflow, and then it's actually doing, let me just expand this guy. Okay, so it's running subflow. Okay. So we are going to, it's running, and eventually it should actually succeed. Okay. And again, you can check the status from the Hue web UI. Okay. So you can just provide the job ID, and so you can, and then you can verify the result. So in this case, we should have actually 2 output. One is WC1, the other one is the WC2, because WC1 is from the first MapReduce job, and this is the second MapReduce job that is running in parallel with the first. Okay. All right. So I'm going to give you guys about 10 minutes to try this exercise. Okay. That's fine. Now we're going to take a look at other action nodes. The action node that you have seen so far is MapReduce action node, but there are other action nodes you can certainly perform. So action node could be MapReduce action node, pick action node, it could be file system action node, it could be scoop action node. You can even send email by using email action node. You can perform some, you can execute some shell script by using shell, the action node. There are in fact more action nodes if you take a look at the document. So we're going to take a look at the few action nodes. This is a pick action node. Okay, so here, the name of the action is pick, and basically the way it specifies that it is an action of pick action is by having a pick element, sub-element under action element. Okay, so here basically we are performing so we job checker, name node, prepare, and the script. So this is the script. The script we are going to execute is a pick/aggregate.pick file, and we're going to take a look at this pick file, and we also provide input and output. So input is fsresult.txt file, and output is pick_result.txt file. Okay, so that's a pick action. File system action here, we can perform we can delete the path, we can make directory, we can move files or directories. Okay, so this is a file system action. And this is a scoop action, so you can perform scoop operation. Okay, so so it's actually performing the scoop import. So it's importing in this case HSQL database to in this output directory. Okay, so this is a scoop action. Shell action, you can specify some shell. Okay, and email action. Okay, so you can specify the to CC subject body, and basically it will send an email. All right, so let's do exercise 3. So in this case, what we are going to do here is that we are going to do MapReduce. We're going to perform MapReduce, and then we're going to actually perform some file operations file system operations, and then we are going to perform pick jobs in sequence. Okay, so let's take a look at the lab documentation. So again, the sample application is provided, and it's called the Oozie multiple. So if you take a look at the tree Oozie multiple. Oops. So we have MapReduce MapReduce configuration file, the same data. So this is exactly the same. And we also have a live. Okay, we also have a job properties. Now we have aggregate pick. Okay, because we're going to actually perform pick action as well. So if you take a look at the workflow.xml file, okay. So we are going to perform MapReduce first. So this is MapReduce job. Okay. Now, once it is successful, then instead of going to end, we are going to go file system action. So you can see this is the FS. Okay. So there is another action that has a name of FS. So this is the file system action. So you can see this is a file system action. So here we are going to delete directory, and we're going to make a directory, and then we are going to copy, basically we are going to copy output WC0. So this is something that we have done in exercise 1. We are copying this part of 00 output file into the target fs result.txt file. Okay, and once that has been successful, then we're going to perform pick pick action. So we go to pick, and here pick, what we do is, we're going to actually take this the fs result text file, and then we're gonna perform pick operation of this guy, pick aggregate pick. Okay, and then the output will be pick result.txt file. Okay, so the pick is, only thing we do is basically we're gonna just get the count of the word. Okay, so nothing fancy. So we're gonna actually do this. We're gonna actually copy to HDFS, and then we are going to run the job. No, not this one. So we are. Oh, okay. So in this case, so whenever URL is not set here, you're gonna actually have this problem. So I'm gonna actually go to this. Yeah, usually it's a good idea to have in your the bash RC file. Okay. URL. Yeah. So I'm gonna just do this one more time. And I'm going to run the job. So I got this job. So this time I'm going to take a look at the status from the Hue Oozie interface. So here I'm gonna go to dashboard. Yes, so I should actually go to dash. Yeah, so if I click the workflow, then it should actually give me all the workflows. Oh, okay, so I'm gonna search. Okay, so this is what's happening right now. Okay, so if I go to this job, So I should actually see, which action node is being performed. So right now it started and it's actually performing map reduce job. Once that is done, it should actually go to FS and then it should go to pick. Okay. And the after FS is done, we should actually see, in fact, the FX result, that text file. And then once pick is done, then we should see the output file as well in the file system. Okay. So that is what's happening. All right, so I'm gonna let you guys to try this exercise. Okay, I'll give you another 10 minutes. No, I'm actually going to exercise 3. Yeah, so you can actually go to these child jobs because we have the uh, yeah, so these are in fact child jobs. So you can take a look at the FS result, the text file. Once the file system action is done, and then you should also see a pick result as well. Okay. Last topic is coordination. Coordination engine triggers the startup workflow based on time. It could be periodical basis. So you want to start your workflow application every 5 minutes or something like that. Or it could be based on data availability. So when new data appears in a directory, you want to have your workflow application to get started. Okay, so both the time or data availability, either option is available. So coordination is specified in the coordinator.xml file. So use case scenarios. So you can have time trigger based execution. So execute a workflow application every 15 minutes. Time and data triggers. Execute the workflow every hour, but only run them when the input data is ready. Okay. Or it could be rolling window. So access 15 minutes of data set and roll them up into an hourly data set. So you want to collect, hourly data set, and basically you want to access every 15 minutes. Okay. Sliding window is access the last 24-hour data set and roll them up every hour. Okay, so these are all possible through coordination. So last example is hands-on lab exercise is exercise 4, coordination. So let's take a look at the coordination. So again, this is provided on the samples Oozie. So if you take a look at the Oozie coordination, you now see coordination XML file. Okay, so you see coordination properties and coordination XML file. So if you take a look at the coordination XML file, okay, so in this case, you can specify the frequency. So in this case, we are going to run this one every 10 minutes. Okay, and the application I'm running is Oozie multiple. So the Oozie multiple application that we just run in exercise 3, what we want to do is we want to run this guy in every 10 minutes. So that's basically what we want to do. Okay. And assuming this job is already in HDFS, right? So we have to copy this guy to HDFS as well. Okay. So we are going to copy this guy. To HDFS. And then so basically application path is a coordination application path is specified with that XML file. okay? And then you're submitting a job, okay? So here we are submitting a job with, yeah, so in here you can also specify starting point and ending point, okay? And the mode is a single, okay? So basically, you know, we are starting this job, I think it's actually at this, you know, right now, and end is plus 1 hour. So within a 1 hour period, we want to run this job every 10 minutes. That's basically what we are doing here, okay? So let's try that. And we can check the job status, and you are going to see, you know, in fact, it has like a 6 jobs lined up. Okay, so this is running at the moment. In 10 minutes, this will be running. In 10 minutes, another 10 minutes, this will be running. Okay, so that's what we are going to see. So this is job ID. So let's take a look at the status. So Oozie. You might want to actually change instead of 5 minutes, you know, 10 minutes, make it 5 minutes so that you can actually see it. But as long as we see this status, that should be good. Oozie job dash info and job ID. All right, so these guys are waiting because it's time yet. Okay, so this the first one is running. Once it's done, it goes the next and so on. Okay. All right, and you can check the status from you know, the Hue web UI. So in this case, you can click coordinators, and then if you click this job, you are going to see, in fact, the this you know, 6 jobs lined up. Okay. All right, so I'm gonna give you 5 minutes for you guys to finish this guy.